Okay, I guess I'm live now. Can someone confirm if I'm live? Okay. Okay, I've got plenty of chat today. It's okay. Salt till C waiting eagerly. You salt till C. E to bata do you guys solutions around 786. CLE on E. Okay, E problem काफी interesting लग रही थी पर solve नहीं. FI किसी वाले में कुछ hint दे दो. Okay, cool. All right. So I'm gonna be solving problem A, B, C, D, E, and F today. I won't be solving G. I wasted all my time on F, so I haven't even read G. Okay, and I got very frustrated on F. How many problems were you all able to do today? Let's see. I think problems till A, B, C, D were easy. E was also easy actually. No, yeah, E and F had little tricks. Okay, A, B, C may confuse. Okay. Okay, cool. Do like the stream, guys. Only 10 likes till now. Someone says 3. Okay. Okay. So I think we should start now. इन्हें काट दिया मेरा. Let's see. I don't really remember the starting problem. Okay. Real Nightbot says 3. Okay. Okay. Anyways, let's start now. Let's start with the very first problem. Okay. Okay. Let me just edit a few things. Edit the title of the video. I am gonna be doing till F. Let me just start. Okay, cool. Okay. Let's start with the very first one. So the first problem says that you are given two integers x and y. You want to choose two strictly positive greater than integers a and b, and then apply the following operation to x exactly a times. Okay. Replace x with b into x. Okay. Okay. So what do we have? We have x and okay. What was it? We have x and this x actually becomes bx, then this becomes b square x, so on till we reach b to the power ax, because we actually do this operation a times. Okay, now you want to find two positive integers a and b such that x becomes equals to y after this process. Okay, so we want b to the power a times x should be equals to y, and we have to find b and a. So the very first condition that we can see is that y percentage x should be equals to 0. Okay, then okay, after doing this we'll actually find y by x, which will actually be equals to b to the power a. Now let's assume a is equals to 1, then b actually becomes y by x. Okay, so that's it. So basically a is always 1, b is always y by x, given that y is divisible by x. That's it. All right, so I hope this is clear to everyone now. E में इतने hacks कैसे हो रहे हैं? Is E getting hacked? Let me see. Which was E breaking the wall? Okay. Many people getting E hacked. Is that so? मेरा ना गलत हो जाए यार. I am a little. I think my E get hacked. Oh, geothermal got a wrong hacked. Okay. Let's see. Let's see what happens. Anyways, I hope problem A is clear to everyone. My hack was unsuccessful. Is that so? Yeah, unsuccessful. Okay, cool. Nice. Okay. So, and let me just show you the code as well for problem A. And okay. Okay. So as you can see, all you had to do was just check if y is divisible by x. If it is divisible, print 1 in y by x, 1 is a and y by x is b. Otherwise, print 0, 0. That's it. Okay, cool. Let's move to problem B now. Okay. Now, I just wanted to say that the effort you are putting into is really useful for those below system. Okay, thank you. Sir, I just same. Next time, ho jayega, bro. Okay, what is the meaning of hacked? I mean, okay, so Akhilesh, basically what hacked means actually is that there are a couple of test cases, okay, which Codeforces already has for every problem, but it might be a case that Codeforces missed a test case and your solution might be giving wrong answer for that. So what you can do is, for example, like if I try to hack someone's code, not from here, like if I actually just a second, let's say if I open this code, my E also got hacked. Really nice. Okay, I was afraid about this. Okay, so I'll actually show you like what happened. Okay, so if you see, my code actually got a wrong answer for a given test for a certain test case. Okay, maybe it will show me also like for which test case I got a wrong answer. See, okay, let okay, so I cannot just a second. Let me see like how do we see the test case in which we get hacked? What is happening with like why is this not visible properly? Anyways, so basically hacking means that someone else actually gives a test case for that your code might give a wrong answer. If my code gives a wrong answer for that, the other person gets points and I get a wrong answer. But since it was a Div-3 round, I don't think other person would be getting any points. Okay. Okay, cool. Anyways, let's move to problem B now. Okay. Now, yeah. The Berlin language consists of words having exactly two letters. Moreover, the first letter of a word is different from the second letter. Any combination of two different Berlin letters, which is by the way, are the same as the lowercase letters of Latin, is the correct word in Berlin language. The Berlin dictionary contains all words of the language. The words are listed in a way that are usually ordered in dictionaries. Formally, word A comes earlier than B in the dictionary in one of the following conditions hold. Okay, so these are the conditions. Okay, anyways. So we are given a word and we need to tell which index this word is gonna lie in the dictionary. So let's see what this dictionary is actually gonna be. The first word in the dictionary will be AB. The reason for this is because we cannot have AA because both the characters are supposed to be different. So we have AA, AC, AD, so on till AZ. The next value that will come will be BA. Then we cannot have BB because both the characters will become same. So we have BC, so on till BZ. Now if you see, these are 25 what do we say, words. Okay, because AA is missing. Similarly, these are 25 words. Similarly for C also you'll see that if the first character is C, then you'll have 25 more words from this. Okay, so if you have A, that means the word is from the first 25 indexes. If we have B in the first character, then it is from the next 25 words and so on. So basically the first character, okay, let's say I took the complete string in S, then the first character actually tells me which section it belongs to. Okay, so basically 25 times S of I, S of 0. If S of 0 is A, that means 0 into 25. If S of 0 is 1, which is B, that means 25 into 1 and so on. Now the next character will be, just a second, let me just get some more board space. Okay, okay. So let's say you had a character S, you had S0 and S of 1. Okay, the first character will actually tell you the section in which it is in. So therefore S 25 times S of 0. Now let's say we were trying to find for AD. Okay, for AD, we would, or let's say take a better example. Let's say EF. We know E is the fifth character. Okay, so since E is the fifth character, we know that it will fifth character. So S of 0 will be 4. That means 25 into 4, that means 100. That means EF will lie somewhere between 100 and 125. Now F is the sixth character. Okay, therefore what? Just add plus 6. Because till 100, we have all the letters still like D, Z. Okay, then we got EA, then we got what? EB, then we had EC, then we had ED, then we had E. We didn't have EE, so we had EF. Now if you see, sorry, this was 5. Okay, because we are having zero base indexing. Now if you see, EF is actually at the 5th place. Sorry, this is 6th only. Okay, and then since it is on the 5th place, the reason is because we skipped EE. So what you need to do is that if S of I or S of 1 is not equal to S of 0, then you need to decrement this. And that's it. Okay, I'll again show you the code as well. Pretty simple. Okay, pretty sure like almost everyone was able to do this. Let me open the code. So in the code, so this is it. Okay, so what I'm actually doing is first I'm actually making finding the set in which it belongs to. Okay, so I say S of 0 minus A times 25. So this tells me the section in which my value belongs in, and then I just say the next character minus A plus 1 because that is the index of the character. Okay, in this I'm not doing plus 1 because we're actually starting from 0 only. Okay, and like the first A values, like the first 25 values for A will be from 0 to 25. Okay, so I have plus 1 here, and then I just see if S of I is greater than S of 0. If it is greater than S of 0, then I decrement my answer. If it is smaller than 0, that means I didn't have to skip any values, therefore the answer remains the same. That's it. Okay, cool. I hope problem B is also clear to everyone. What is the okay? Where virtual context is helping? Can you explain more the context? पहले भी मैं ऐसे लॉजिक कुछ सोच रहा था फिर देखा कंस्ट्रेंट बहुत कम है. Okay, brute force. Okay, cool. Okay, anyways. Harshad Gupta says, could you explain recursion part from last contest problem? Okay, we'll see if we have time in the end. I'll explain this to you, or you can just what you can do is you can just DM me on Codeforces. I'll explain you in the text only. I'll send you the code or something. Cool. Anyways, let's start with problem C now. Okay. Okay, let's see problem C now. You're given a string S consisting only of Latin letters A, okay, and a string T consisting of lower Latin letters, okay. In one move, you can replace any letter A in the string with the string T. So the very first string is S, which only has A. So let's say it had 4 A's. Now we have another string which is T. Okay. Now you can perform any arbitrary number of moves, including 0. How many different strings can be obtained from the number? Okay. What we can do is we can actually replace any letter A in the string S with the string T. So let's say string T is what? AB. And let's say this S was AA only. Okay. What we could have done was, okay, yeah, what we, let's say this was BC. That is simpler. What we could, so we had AA. We could either replace this A and make this BCA, or we could replace this A and make this B what? ABC, or we could replace both of these and make AB AB. So we can make 4 ways. Okay. Now what if we had an A here? If we had an A here, you will see that we had A in the start. We would actually replace this A with ABC. So we make ABCA. Now if you see, the number of A's remain the same. That means you can now again include ABC either here or here. So you see, the strings will keep on increasing. And there will be infinitely strings. Which actually tells us that if T has an A, then the answer is infinite. But there is one edge case if T is equal to a single A. If T is equal to single A, you will see that when you replace this A with A only, the string remains the same. So the total number of distinct strings will be 1 only. Okay. So if T doesn't have an A, okay, we'll come on to doesn't have an A. If T has an A, okay, and if the size of T is 1, then the answer is 1 only. If T has an A and size of T is greater than 1, then the answer is infinite. Okay. If T doesn't have any A, let's say BC, then we saw that at every A we could actually place this BC. Okay, so for the very first A, we can either place this BC or cannot place the C. So two turns. For the next index also, we can either place BC or we cannot place BC. So again, two turns. So basically, 2 times length of T. And that these are the three answers. Okay. So again, I'll show the code. Again, pretty simple. Okay. Let me show the code as well. So this is the code. What we're actually doing is, I have A as S, B as T. First, I'm checking in T that if I have an A, I make my flag equals to 1. If my flag is equals to 1, and if my size of like T is equals to 1, then I print 1. Otherwise, I print -1 because I have infinite things possible. Else, what I do is I make 2 to the power of size of S. Okay, this was S. Okay, so yeah, that's it. This thing you have to make sure that you actually use long for this, because this is 2 to the power of 50, which is actually greater than 10 to the power 9. So you have to use long. Okay, cool. I hope this problem is also clear to everyone. Okay, cool. Let's move on to problem D. I'm pretty sure like nobody has any doubts till now. Let's move to problem D now. Okay. Can someone tell me like for which test case E is getting hacked? Maybe I can try checking like what I missed. Okay, cool. Let's start with problem D now. Okay. Let me just decrease the size. You're given three arrays A, B, C. Initially, array A consists of n elements. Array B and C are empty. Okay, so let's say we had an array A. This is array A. Okay, B and C are empty. You're performing the following algorithm that consists of 2 steps. While A is not empty, you take the last element from A and move it in the middle of B. Okay, so we take the last element of A, move it in the middle of B. Okay, if B currently has odd length, you can choose place the element from A to the left or the right of the middle, or left or the right of the middle of B. As a result, A becomes empty and B consists of n elements. Okay, cool. Step 2 says that while B is not empty, you take the middle element from B and move it to the end of array C. If B currently has even length, you can choose which of the following 2 elements will it take place. Okay, cool. So let's see. Okay, I'll directly jump on to like what all we have to do. So we had, let's say my very first string had A1, A2, A3, A4. Let's say it was an even length array. While making B, we know that the very first character that will come will be A4. The next one that will come will be A3. Now A3 can actually come either on the left of the middle or on the right of the middle. So we have two possibilities. One is A3, A4 or A4, A3. After that, we get A2, which will come in the middle of both these. So we have what? A3, A2, A4. Okay. And here we have A4, A2, A3. Then we are left with A1, which will actually come either on the left side of A2 or on the right side of A2. So we have A3, A1, A2, A4, or we could have A3, A2, A1, A4. And from this, we could actually get A4, A1, A2, A3, or we could get A4, A2, A1, A3. Now, if you see, so let's see what are the things possible. We either had A3, A1. Okay, so this is B. These are 4 possibilities for B. Okay, so we have what? A3, A1, A2, A4. Then we had A3, A2, A1, A4. Then we had A4, A1, A2, A3. And we had A4, A2, A1, A3. So these are the 4 possibilities for B we had. Okay. Now, while making C, what we have to do is you take the middle element from B and move it to the end of C. If B has even length, then you can choose which of the 2 middle elements to take. Okay. Now, if you see, okay, let's take any random B. Okay. Let's say we took any random B, which was the first one. We had A3, A1, A2, A4. Now we have to take the middle element of B. So we could either take A1 or A2. Let's say we took A1 here and A2 here. If we took A1, okay, then the next element would be A2 only. So we get A1, A2. And this will get A2, A1. Okay, then we are left with A3 and A4. So we could either take A3 or A4. So we have A1, A2, A3, or we have A1, A2, A4. Similarly, for this one, we have A2, A1, A3, or we have A2, A1, A4. Then we are left with the last value only. So this will make A1, A2, A3, A4. This will make A1, A2, A4, A3. This will make A2, A1, A3, A4. And this will make A2, A1, A4, A3. Now, if you actually see what are all the possible swaps done, okay, we have 2, 3 in place, still in place, okay, but 1 and 4 also in place, okay. The other case, just a second, did I do something? Why is 2? Okay, I think I did something. Just a second. A2, A1, A2, A1. So this has A2, A1, A3. Okay, A2, A1. Yeah. Oh yeah, cool, cool, cool. Okay, so if you see, A1 and A2 are in place, A3 and A4 are also in place. Okay. Now in this one, A1 and A2 are in place, A4 and A3 got reversed. In this one, A2 and A3 got reversed, A3 and A4 are in place. In this, these two also got reversed and these two also got reversed. So basically, if you see, if you had A1, A2, A3, A4, you could swap these two also and these two also, but you could not swap any other value. Okay, so if you have an even length string, then you can take the first two elements, swap them, next two elements, swap them, next two elements, swap them, next two elements, swap them, depending upon which one is greater. Okay, because you want a non-decreasing order. Okay, so if this value is greater than this value, then you can swap them. Okay, if that is not the case, keep them as it is. Okay, now if you'll see for odd case, if you have like A1, A2, A3, A4, A5, you will see that in the end, A1 will stay in place, but A2, A3 will be swapped and A4, A5 will be swapped. And that's it. So basically, if it is even, then start from 0, swap every two values. Okay. Depending upon which is bigger. Okay, if it is odd, then start from 1, and then do the same thing, swap every two values depending upon which is bigger. So apparently if you have like xy, okay, and if x is greater than y, then make them yx. Otherwise, if x is less than y, then keep them xy only, less than equal. That's it. So I'll show my code. Okay. Okay. Okay, so this is the code. Okay, so first I've just scanned the array. Okay, then depending upon the polarity of n, if n is even, you see if n is even, then n percentage 2 will be 0 only. So I'm starting from 0. If n is odd, then I'm actually starting from 1. Then for every two values, I'm checking if my array I is greater than array I plus 1. If it is greater, I just swap the values. Okay. If they are not greater, I keep the values as it is. Then in the end, I just see if my array is non-decreasing. If it is non-decreasing, then I print yes. Otherwise, I print no. That's it. Okay. How to did you solve all Codeforces contest? No, I tend to skip some contests. Okay. Not like I give every contest. Sir, I'm 3-star on CodeShare, but still can't solve problems on Div-3. Codeforces, please give me some to improve CP skills. Keep practicing, Avril. That's it. Try to absolve previous Div-3s as well. Try to give more virtual contests for Div-3 if that's the case. भाई मिड कॉन्टेस्ट क्या ये टेबल कंस्ट्रक्ट करके देखा आपने ये इंट्यूशन से ही? नो, आई डिडंट एक्चुअली मेक द कंप्लीट टेबल. I actually just made the array b and got realized that this will be happening and then just coded it. I didn't really make the entire thing. Okay. All right. Let's move to problem E now. Okay. Okay. First, can someone tell me like what test case is failing for problem E? Because I see many hacks. Even my problem got hacked. So I need to know like what I'm missing so that I can actually explain. Okay. I'm just looking at problem E, like how to do that, like what is missing. If anyone else gets to know, they can just tell me, or else like give me a minute. Okay, so miss this case. Okay, can someone tell me like what did I miss? Or should we jump to problem F first and then we can do E? So you could, like, can you just give me a minute? I'm just trying to figure out like what I did wrong. I have A by 2. Okay, I think we can discuss now. Okay, let's just start with problem E only, and let's see like what I'm doing wrong. Okay. Okay. So basically the problem says that the wall consists of n sections. Okay, cool. The wall consists of n sections aligned in a row. The ith section initially has durability AI. Okay, so we have a wall of length n, a1, a2, and so on till an. Okay. The durability of some section becomes 0 or less. The section is considered broken. Okay. To attack the opponent, monocraft needs to break at least two sections of the wall. Any two sections, possibly adjacent, possibly not. To do this, he plans to use an onager, special siege weapon. The onager can be used to shoot any section of the wall. The shot deals 2 damage of the target. Okay, so basically if you're targeting at this point, okay, so this gets a -2, the left one gets a -1, and the right one gets a -1. Okay, so this is what is mentioned here. Okay, monograph can shoot at any section any number of times. He can even shoot at broken sections. Monograph wants to calculate the minimum number of onager shots needed to break at least two sections. Help him. So as you can see in the very first test case, we have 20, 10, 30, 10, and 20. So if you see, there are multiple ways of actually breaking all of these. You can either do 10 shots here. This will actually become like -20. This will get -10, and this will get -10. So this will become 0, this will become 10, and this will become 0. So since this and this are 0, therefore we can say that in 10 shots, we're able to break at least 2 points in this wall. Okay. The other way could have been, we could have actually made all those here. Then this would have become 0, and this would have also become 0, because this would have actually got -20. This would have got -10. Okay. In the next case, if you see, we have 181. What you can do is you can just shoot in the center one time. This gets -2, this gets -1, this gets -1. The updated array becomes 0, 6, 0. Two walls are broken now, therefore we could do that in one blow only, and so on. Okay, now let's consider all the cases. Okay, the first case could be that this was the complete wall. We could have broken one wall here and one wall here. Okay, since we broke one wall here, one wall here, the consecutive adjacent parts had no role, adjacent parts had no role. That means if this was x, the number of times we had to blow here in order to break this one would have been x plus 1 by 2. For example, if x is 5, then it would have required 5 plus 1 by 2, which is 3. In 3 blows, we could have broken this wall. Similarly, for this part also, so if this is x, this is y, then the answer would be x plus 1 by 2, y plus 1 by 2. If x and y are not adjacent. Okay, that is one case. Okay, also, since you are doing this, you will ensure that x and y are the smallest values possible. Okay, so you can just sort the complete array in the end. Okay, and then see take the smallest two values, and then like find x plus 1 by 2 and y plus 1 by 2, and see if this is minimum. Or the other way would be if you consider both the points. Okay, if you consider both the points adjacent, or if you consider both the points with one gap. If it is one gap, okay, then it will be like you will blow every time here, and whatever is the maximum of, if this is x, this is y. Okay, in one blow, this will become x minus 1, this will become y minus 1. In order to make both of these 0, you will actually have to take maximum of x comma y. If let's say y is bigger, then you have to blow in the center y times, so that this becomes both these walls are broken. Okay, in this case, okay, when we have two adjacent, we'll actually apply a property here. If this is x, this is y. Okay, if x is, sorry, if y is, let's say y is bigger, if y is greater than 2x, if y is greater than 2x, okay, if y is greater than 2x, that means we just have to break y, and x will automatically break, because x receives -2, y will receive -2, and x will receive -1. Okay, so if we are making like 2x blows here, then this will become -x only, and like that will be done. So if y is greater than 2x, then y is the answer. But if y is less than 2x, if y is less than 2x. Okay, then we actually have a property which says that x plus y plus 2 by 3 will be the answer. I'll tell you like how this works. Okay, this I'll explain, but that is precisely the answer that I wrote, and like I actually got a wrong answer. I do have an int, like I actually thought of just one thing while explaining to you guys, that maybe I missed. No, that I've already done. I still don't know like what is wrong with my code. Should I go ahead and like explain all of this? Test case falling for E. Okay, 23, 23, 5057. My code will give 57 for this one. I don't know like what is wrong in this one. Uh, max of xy is wrong, I guess, with one gap. Why is this wrong? I don't really understand. Oh, no, you are right. You are actually right. Yes, I missed this. So, okay. Okay, now I know like what I missed. Okay. So basically, if I take x here, y here with one gap, it will actually be minimum of x comma y plus y minus x plus 1 by 2. Yeah, this is the answer. And you're saying for 23, 5057, my answer would be like 23 plus 57 minus 23 is what? 24? Sorry, what am I doing? 34. Okay, 34 plus 1 by 2, which makes 17. So this will be 40. My answer for this case will be 40. Is this the answer? Ashish says, please read my comment. Okay, let me just see. Ashish, what is the procedure of hacking? Can anyone tell? Oh, sorry, no, that is Akash. Ashish says no audio. Is that so? I think everybody else is able to see the audio. I hope everyone has the audio. Yeah, I think everybody is getting my audio. Correct answer is 40. Yes, I'm getting 40. Okay, now I know like what I missed. Okay, let me just explain like what all things had to be done. Okay. And then I'll just resubmit my code. Okay, cool. Okay, so let me just remove my screen and show. Okay, there are a couple of cases. The first case is that, okay, the first case is when you have x here, y here, okay, and they are at very far distance. Okay, what you have to do is sort first. After sorting, answer will be x plus 1 by 2 and plus y plus 1 by 2. Okay, the reason for this is because if you have x which is odd, then odd plus 1 becomes even by 2. Okay, and if it is already even, even plus 1 by 2 is anyways this case. Okay, so this is the first case. Okay, the next case is when we have a gap of 1. So let's say x is here, y is here. Okay, in this one, what you have to do is, okay, what you need to do is, you'll first make all the, yeah, you'll first blow all the cases in the middle such that, like, let's say x is minimum. Okay, then your answer will be, let's suppose x is less than y for now. Okay, then your answer will be x plus y minus x plus 1 by 2. No, it should be x by 2. The answer will be, no, one case would be x plus y minus x plus 1 by 2. The other case would be, no, that will be already covered. Yeah, this should be the case. Okay, so x plus y minus x plus 1 by, just a second. She says, please read my previous comments. Uh, Let me just see. My comment is not showing up. I can't see your comment, Ashish. Can you just Repost your comment again. Please prove it as well. I'm getting 40 only, then also got hacked. Okay, is that so? Like, is 40 not the right answer for 23 5,000? The other part was 57. Yeah. Is 40 not the right answer? The answer is 57 plus 23 by 2. Oh, is it 57 plus 23 by 2? Really? How? How can we do that? Okay. Minimum of max of xy. Max of xy. Okay. Then you get max of x comma a plus. What is a here? Answer is 23 plus 57 by 2. How? Okay. Okay, I got it. So basically, you first make 11 blows here, and you make 23 blows here. Okay. This will be 1, this will be 1, and then you make 1 blow here. This actually makes what? How much? 35. So 35 becomes the answer. Okay. Interesting. What if this was 24? Will this still work? No, for 24 this would work then. This only works. It should be x plus y plus 1 by 2. Oh, this is that only. This is 2x by 2. So this is x plus y plus 1 by 2 only. Yes. So in this case, we had what? 60, 70, 80. How is this 35? Have I counted right? 11 blows for this one. This is wrong. This is what? How much? 56 by 2 is actually 28. 28 blows for this one. Okay. So this becomes actually again 40 only. Still not getting. Still not getting like what I'm missing. Okay, so let's do this again. So we have this point. Okay, x is here, y is here, and we have something in the middle. Okay, one way would be we first make all the blows here. So we make x by 2 blows here. We make y by 2 blows here. If some value is still left for these two, then we make one more blow. One way would be this. Okay, this one depends if x, both x and y are hot. Uh, can you see SSRS underscore code? Okay, let's see. I believe he was somewhere in the okay first one. Okay, so what this person has done is yeah, this is the case. If AI is less than AI plus 2, okay, this is x, this is y, then what this person has done is x plus, so we have x plus y minus x plus 1 by 2. Yeah, that is what I wrote actually, but like this gives again 40 only, I think. We have 25,000 and what 57. 23. So this is 23 plus y minus x. 57 minus 23 is actually 34 plus 1 by 2, which is what 17. So this gives 40 only. Am I doing like something very wrong, or like 40 is the right answer? Let me just like change my code and try to submit. Maybe like 40 is the right answer. Let me copy my code. problem. Yeah, I need to change which case? This case. This has to be array I minus 1 plus array I plus 1 minus array I minus 1 plus 1 by 2. This is when array, if array I is less than array I plus 1, the array I minus 1. Else I do the same. I do the same thing, but this is I plus 1, array I minus 1, array I. Let's see if this goes right. Oh, I am not showing my screen. That's so. Okay, so what I've actually done is if array is less than array I plus 1, array I minus 1 plus array I plus 1, 2. Yeah, perfect. Or array I plus 1, array I minus. Yeah, cool. Let's try to submit. Then let's see. This gives a right answer. Accepted. Okay, cool. Okay, yeah, this is the logic, guys. Okay. So basically, this is the logic: x plus y minus x plus 1 by 2. The reason is that we first make all the blows for this x. Okay. Okay, so we make for x plus 1 by 2. We first make all the blows for the center one. Okay, this gets reduced by x times. Okay, so x blows for this one. Okay, then this is also reduced by x, so we make y minus x plus 1 by 2. Okay, that's it. Okay, so this is when we have a gap of 1, and the last part is when there is no gap. Okay, when there is no gap, when it is just x and y. Okay, the first condition is that if y is greater than 2x. If y is greater than 2x, that means all the blows will be for y only, because while blowing y, x will already get destroyed because x is actually less than y by 2. Okay, so the answer for this case will be y plus 1 by 2. But the other case, when y is actually less than 2x, what do we do then? The answer for this is x plus y minus 2 by 3. How do we get this? Okay, the way we get this is okay. The way we get this is how do I explain this approach? Yeah. So basically, in every blow, if you see, you do -2 for one person and -1 for the other person. So in total, you are actually doing this -3. So if your sum is x plus y, okay, okay. If you divide this by 3, this should be your answer. Okay. But since like you might still be left with some remainder after this, okay, you actually need to add +2. Basically, like if you have to divide n by 4 also, okay, the best way to do this is n plus 3 by 4. So that you actually see like if in the last section some values were left as a reminder, they are also covered. Okay. So yeah, x plus y plus 2 by 3. That is how you get this. Okay. So if y is less than 2x, then you have to do x plus y plus 2 by 3. That's it. Cool. I hope this problem is also clear. Let me just show my code so that everyone now understands it pretty well. I'll like explain like all the three conditions again in the code. Okay. So yeah, this Okay, so this is the code. Let me just try to explain like what is going on here. Okay, so this is the condition for the last one, the last condition which I discussed, that if x and y are adjacent. Okay, if x and y are adjacent and y is the greater of the two values, x is the smaller of the two values. If y is greater than 2x, that means you just need to destroy what? You just need to destroy y. There's no need of destroying x. Okay, I've actually complicated it here. You just had to write temp answer plus equals to y plus 1 by 2. There is no need of doing this part. Okay, else what you have to do is x plus y plus 2 by 3. If y is less than 2x, then you just have to count x plus y plus 2 by 3. Okay, yeah, then answer equals to minimum of answer comma temp answer. Then in the next cases, when there is a gap of 1, when there is a gap of 1, and let's assume that array of I minus 1 is less than array of I plus 1, then the smaller value plus large minus smaller value plus 1 by 2. Okay, and this is the opposite case when the array I plus 1 is less than array I minus 1. Okay, and then the last case is that when they are very far away, you sort the complete array first and then find the smallest two values and then do array 0 plus 1 by 2 and array 1 plus 1 by 2. That's it. That's all. Okay, cool. I hope this is also clear to everyone. Even I got confused in this one, got a hacked one also. Okay, let me read the chat. Okay, can you repeat use binary search? No, I don't think anyone used binary search for this one. I don't think there's any use of binary search. Why are you not reading my comments? Ashish, I'm not able to see your comment, whichever comment you're telling me. Okay, maybe there is some issue. Okay, cool. Didn't understand, please repeat. I still need to repeat? I think I explained the code again. Okay, pretty sure like you are able to understand now. Okay, cool. Let's move to problem F now. We wasted a lot of time on problem E. Let's move to problem F now. Alright. In the contest, I got very frustrated on F. Okay, for no reason. Like I had the code in front of me. I knew like this was right. I was just missing something, and like it took me a lot of time to solve it. Okay, anyways, let's see. So I won't read the problem statement. I'll just explain you like what the problem statement is trying to say. So what we have is we actually have a grid. In the first case, we have a grid of 4 cross 4. So I'll make a grid of 4 cross 4. Okay, and we have some computers. Okay, some icons. Let's just try to see this window as a desktop. Okay, and we have some computers present at this position, some icons present at this position, this position, this position, this position, and this position. Okay, now if you see in an idle desktop, the way we try to organize our desktop is that we would actually want all these icons to be organized in a way in order, that is like this, this. Since we have 5 icons, so 5 icons like this. What you need to do is you need to tell how many times you need to pick an icon and place it somewhere else so that this reaches this configuration. Now for this case, if you see, you need to pick this one and place it in the first one, this one to place it here, this one to be placed here, and this one to be placed here, and in total you will make 4 moves. Now you are given some queries. The queries say that at 1 comma 3, at 1 comma 3, so in the first row at the third index, you revert whatever is present. So if it is an icon, you delete the icon. If there is no icon, you bring an icon there. So what they're saying is you actually delete this icon. If you delete this icon, you will see that this icon will be removed from here, and in total if you see 3 moves are required now. Therefore the answer is 3. For the next case, when you have 2 3, in second row, go to the third column and place an icon. Now if you see, you will again have to bring an icon here. Okay, and in total 4 moves are required. So the answer for the second case is 4. In the third one, it is 3 comma 1. So in the third row, first column, which is this one, we have to remove this icon. Now if you see, this icon will be removed, and in total again 4 moves are required. Okay, and so on for all the queries. The first thing to notice in this is that the answer is always either getting increased by 1 or decreased by 1. Okay, so let's first assume, let's leave this right here. Okay, and let's take a grid. Let's take a 4 into 4 grid only. Okay, let's say this was the grid. Okay, and okay, let's take the same example only. Let's say we had this present here, this present here, this present, this present, and this present. And in organizing, what we had to do was we made this. I'll first tell you like how to solve this, then I'll tell you a trick on like how you can actually solve this very easy. Okay, so this is the ideal desktop that we had to make. Okay, now the very first query says that 1 comma 3, or how do we do? Let's assume we had to insert another what say, okay, let's remove this one and place it here only. Okay, now let's assume we had to insert another icon at this place. Now if you see, since we had to insert another icon, okay, and since all the we know that our desktop is filled till this place, so this portion of the desktop is filled. Now you know that the index where you have to place another icon is actually outside this region. Therefore, whatever the answer you had before should be increased by 1. Okay, so increase your this by 1. Okay, let me remove the screen. Yeah. Okay, if the value was outside, then answer becomes +1 since it was outside. Now you will see that since it is outside, this value will actually come at this index. What if this index was already filled? If next index is already filled, then you do answer -1. Okay, these are the two conditions while adding computer, add icon, sorry. If the value that you're going to include is outside the region where you want to include, then you increment your answer by 1. The next thing you see is that if the next index which will be filled has an icon, then you do answer -1. The reason for this is because you already have an icon here. That means you don't need to replace this icon with something else or move this icon. But before this case, you actually had to move this icon. The reason for that was because, let's say this was here only. The reason for that was because in this case, when I didn't put this icon, you actually had to take this icon and place it either in any other place. But now when you actually got an icon here, this icon will stay at this position only, and this icon will go at the position of the previous where this was going. Okay, so answer -1. And the same thing for remove icon. If you have to remove an icon, then what you have to see is if it is present inside. Okay, so let's just say we were trying to remove this icon. If it was present inside, okay, then you increase your answer, because now you actually need to take another icon and bring it here. Also, okay, if this index was already filled, let's say this was actually present here. If this index was already filled, or not this one, this one only, I think. This is 4 moves here also. what is the condition that I'm missing? If you are removing actually, then what you have to do is, sorry, if I'm removing, yeah, right. If I'm removing, then this index gets taken. Yeah, cool. Okay. Okay. Basically, when you're removing, okay, when you're removing, and if it is present outside, okay, what if this was the case, okay, and you removed this icon? If you remove this icon, that means your answer will decrease. Your answer will decrease. The reason is because now you don't have to move this icon. The other condition is that if, let's say this one, let's say this was present here. If current index is filled, if current index is filled, which is this index, and now if you have to remove this one, we know that after removing this one, this icon will also be removed. But since this, we already had an icon present here, we didn't remove this icon, but now we'll actually have to move this icon. So we'll need to increase our answer by +1. So these are the conditions that you had to write. Now the implementation of this becomes very difficult. In order to simplify the what do we say, implementation, what we had to do was, if you see, instead of considering this as a 2D grid, what we could have done is, let's assume like this icon was 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. What we could have done is, we could have actually made a single array. Let's suppose the first index was 1, second was 2, third was 3, fourth was 4, fifth was 5. The reason is because we know that after 4 we need to look at 5, because that is how the desktop is arranged. So you could actually convert this complete grid of 2D into a 1D grid and then solve the complete problem. Okay. Okay, cool. Let me show my code, like how this has to be done, and maybe things will get clear with that. Okay, so this is the code. Okay, so basically what I'm actually doing here is, I made an array of n plus n into 1 plus 1, because I actually have to make a single 1D array only, and in the complete grid we have n into m elements. I wanted one base indexing. Okay, cool. After that, I'm just scanning the complete array. Okay, if my index is, okay, so if in my grid my index is I comma j, now my index actually becomes j times, sorry, j minus 1 times n plus I. The reason for this is because I know that in the ith row I am at jth column. So in order to reach the jth column, okay, so this is first column, this is second column, third column, let's say j was 3. I know that 1 till 8 indexes are gone. So j minus 1 is 2, 2 times n is 4, so this is 8. 8 indexes are passed through this, plus I, plus the index, plus the row which I'm at. Okay, so plus I. So this is the index that I need to store for. So I make array of j minus 1 times n plus I equals to c. Then what I do is, I just see, okay, then I see like my current answer. Okay, before making any queries, I just see how many values are outside. So for this grid, okay, let's say we had this at here, then at here, here. So this was the initial grid. Okay, we will see our index actually reaches here, that we have 5 values. So these icons should be filled. All the icons which are outside this one should be moved. Okay, so we just count all these values and the answer becomes equals to 4 here. Then after this, I've actually written all the 4 conditions which I mentioned. The conditions are, okay, do I need to explain these conditions? Okay, so x and y are the query which I'm saying. I make x equals to x plus equals to y minus 1. So x becomes the index in my 1D array. That at index x, I need to toggle whatever is present. So if already I have a dot here, that means I don't have any icon there. Place an icon, see if x is greater than count, that means if the what do we say, like the current covered window, okay, if x is greater than the current covered window, that means answer plus plus, because I'll have to actually move this new icon to the covered place. Okay, so answer plus plus or count plus plus. Okay, or okay, if the new value, the new index which I'm acquiring now in my covered window, if that already has an icon, then answer minus minus. Similarly, if I'm removing an icon, first remove the icon from that index, count minus minus, then see if my previous index window which I was covered, if the last index was of that was had an icon. If it had an icon, then answer plus plus, because now I need to move that icon. Okay. Else, other part is that if x is greater than count plus one. Okay. If I removed an icon from the window which was not covered, okay, then answer minus minus, because I don't have to move that value now. And that's it. Okay, cool. I hope this is also clear to everyone. A little tricky, okay, but like just try to spend some time with this code and you'll hopefully be able to understand this one. Okay, cool. I think that's it for the stream. Do like the stream, guys. And okay, we covered problems from A to F. Okay, I still don't know. Like I haven't read problem G, so I can't really say like how what needs to be done in this one. But yeah, I'm pretty sure like everybody now knows the solutions from A to F. Okay. Okay, cool.